Why is division by zero undefined in mathematics? Division fundamentally asks how many times one number fits into another. For example, 10 divided by 2 equals 5 means that 2 fits into 10 exactly 5 times. However, when we try to divide by zero, we're asking how many times does zero fit into a number? This creates a logical problem. Since 0 times any number equals 0, 0 would theoretically need to fit an infinite number of times into any non-zero number, which creates a logical issue. Let's see the algebraic contradiction. If 10 divided by 0 equals some number n, then 0 times n should equal 10. But 0 times any number always equals 0, which means 0 equals 10. This is a contradiction. Another way to understand division by zero is to look at it as a fraction. Let's see what happens as the denominator gets smaller and smaller. When we divide 10 by smaller and smaller numbers, the result gets larger and larger. As the denominator approaches zero, the result approaches infinity. But as the denominator actually equals zero, we encounter a problem. The result is not just very large, it's not defined at all. In summary, division by zero is undefined for three main reasons. First, it leads to algebraic contradictions. Second, as the denominator approaches zero, the result approaches infinity without reaching a specific value. And third, division by zero doesn't have a single consistent value. Therefore, mathematicians define division by zero as undefined. What would happen if we assumed division by zero was possible? Let's start with a simple assumption that a divided by zero equals some value b. Let's prove why this assumption leads to a contradiction. If a divided by zero equals b, then we can multiply both sides by zero to get a equals b times zero. But any number times zero equals zero, so a must equal zero. This means that any number a would have to equal zero. But this creates an obvious contradiction. 5 would equal 0, 42 would equal 0, pi would equal 0. Clearly impossible. Here's another famous proof that shows how allowing division by zero leads to absurdity. Let's prove that 1 equals 2. Multiply both sides by a, which gives us a squared equals a times b. Subtract b squared from both sides and factor the left side. Divide both sides by a minus b. Since we assumed a equals b at the start, then a minus b equals 0, and we've divided by 0. Continuing with our flawed logic, we substitute a equals b. This simplifies to 2b equals b, which means 2 equals 1. An obvious contradiction. Let's explore a real-world implication in physics. Speed calculation. Imagine a car traveling 6 meters in t seconds. The speed formula is distance divided by time. But what if time equals 0? This would give us speed equals 6 divided by 0. This would imply instantaneous teleportation. The car moving from start to finish with no time passing, which violates the laws of physics. In computer programming, division by zero is a common source of errors and program crashes. When a program attempts to divide by zero, it can't represent the undefined result and crashes with an error message. Computers are built on mathematical principles. Since division by zero is mathematically undefined, computers cannot represent such results. To conclude, the prohibition against dividing by zero isn't arbitrary. It's essential for avoiding mathematical contradictions, preserving logical consistency, enabling accurate physical models, and preventing computational errors. Division by zero must remain undefined for mathematics to be consistent and useful in describing our world.